So, good morning, everyone. Good morning. Good day, everyone. So, in this lesson, we will discuss about fluid mechanics. So, first, let us define what is fluid. So, fluids, including liquids and gases, are substances that deform continuously under the application of a shearing force. They lack a fixed shape and readily adapt to the shape of their container. So, ang fluids is unlike solid is less compact siya. Dayon this it is a substance that will continually deform flows under the action of shear stress. So, for example, natay plane tapos nay solid sa ihang baba nay liquid sa babaw, and then there's a for example is nay floating kuan diha, let's say sponge. Kung so if ever push na to ang katong sponge, ang direction sa sponge, so dadto sa siya paingon ang fluid, no, mo na siya ang katong sa sa shear stress. And then they lack a fixed shape and readily to adapt to a shape. So ang ihang shape is vary ra gid siya sa ihang sudlanan, yung container. So next is density. So density is defined as mass per unit volume, or it is given by the symbol rho. In the equation form, rho equals m over v, which is mass over volume. It is a crucial property for determining whether an object will float or sink in a fluid. The density of a substance can vary depending on its composition, phase, and temperature. So example na to na is 1 kilogram of iron nails o 1 kilogram of cotton. So parehas na sila mass, kay parehas na sila kuan, parehas sila og kilo, so 1 kilogram sila duha. Pero ang cotton is mas dako siya volume kaysa sa nails. So ang formula sa sa density is P is equal mass over volume. So ang gingon sa density is ang imong mass is directly proportional sa imong density. So pasabot og taas imong mass, taas pod imong density. Pero ang sa volume is inversely proportional na siya. So kung taas imong volume, so mogamay imong density. So sa case atong example is, although pareha sila mass 1 kilogram, maglahi-lahi mo siya kay since ang volume nila is galahi-lahi. Since dako ang volume og cotton, then mogamay ang density. Therefore, mo to ang hinungdan nga molutaw siya. So if ang imong density sa imong object is mas gamay siya kaysa sa density sa water, mo nang hinungdan nga molutaw ang isa ka object. Para sa iceberg, ang density sa iceberg is 0.9 grams per centimeter cube, while ang sa water is 1 gram per centimeter cube. So mas gamay man ang density sa iceberg by 10%, mo nang hinungdan nga molutaw siya. So kining nasa babaw sa iceberg is 10% ra na siya. So if ang imong object is mas taas ang density kaysa sa density sa liquid, so mo nang hinungdan nga the object sinks in liquid. So example is kining mga bato is mas dagko ni ang density kaysa sa water. Mo nang naagit siya sa gasink gid siya sa tubig. Same gyapon siya sa coins. Kay sink gyapon siya since dagko man yang density kaysa sa water. So if ang imong object is proportional ihang density sa imong liquid, then the object is fully submerged in the liquid. Fully submerged meaning walay mulapas nga part sa imuha nga mulapas sa tubig, pero dili ka ga sink sa lalong. So example is kaning mga submarine. Wala siya wala siya galutaw, wala siya lutaw sa babaw, pero wala po siya lugdang. Kay since ang ihang density is similar naman siya sa imong kuan density sa water. So for example, a wooden box weighs 10 kilograms and its dimension are 1 meter by 2 meter by 0.5 meter. What is the density of the wooden box if the box will be thrown out in the water? So given atong mass no, which is 10 kilogram. So ang volume na to is pagkuha na to sa volume is length times width times height, since given ang dimensions sa box ato ra siyang i-multiply, which ang result niya is 1 meter cube. So ang pangutana, mo lutaw ba siya or mo 1 lugdang. So kuha na to yung density, i-divide na to ang 10 kilogram sa 1 cubic meter. So ang answer is 10 kilogram per cubic meter. So ang density sa itong water is 1,000 kg per cubic meter. So since gamay kaya itong density sa itong box, so pasabot mag-float siya kay since gamay ang density. So next is the specific gravity. So specific gravity is the ratio of the density of a substance to the density of water at 4 degrees Celsius. It provides a dimensionless comparison of densities without needing to consider units. So sa atong example gay na atong nakuha is 10 kg per cubic meter. So kung kuha nimo ang specific gravity, ato ara nang tanggalon iyang sign. Mao na ito imong answer. So another example, a rectangular block measures 2.3 cm times 5.1 cm times 7.8 cm. It has a mass of 66 grams. Determine its specific gravity. So sa pagkuha sa specific gravity, that is density sa substance over density sa water. So since given man ang mga dimensions, kuha na to yung volume. So volume sa rectangular block is length times width times height. So i-multiply na to ni siya tanan. So ang atong volume is 91.5 cubic centimeter. So given yung mass which is 66 grams and pagkuha sa iyang density which is mass over volume. So i-divide na to 66 grams over 91.5 cubic centimeter. So this is approximately 0.72 grams per cubic centimeter. So pagkuha na to sa iyang specific gravity, kuha na to ina iyang unit. So ang mabilin is 0.72. Muna na itong answer. So next is pressure, which is given by the symbol P, is defined as the normal force per unit area. So ang equation form niya is P is equal to F over A, which is force over area. It is a scalar quantity and acts perpendicular to any surface it contacts. Pressure in a fluid increase with depth due to the weight of the fluid above. So explain na to dre sa atong example no kung unsay use sa pressure. So ang pressure mo na siya mag-explain nganong ang galisod ang mga babae gamit og high heels. So diri man sa mga heels sa heels sa mga babae is gamay kay siya area. Dayon, for example, ang force is mo na siya ang kabugaton sa babae. Imagine bugat kay siya unya gamay kay dirang area, sakit kay siya sa tiil. Pag gamay magug kay siya ang iyang ang area tapos dako kay ang force, so grabe gid ang pressure ana. So mo nang sakit kayo sa babae. So next nato nga example is ang kutsilyo. So di ba pag maggamit ang kutsilyo pag mag-slice ta diri ta magunit sa likod. So kining sa sa likod is baga na siya lapit mo nang dako na siya ra area. Mas dako siya area kaysa sa pikas kay diri man gadot. Sa pikas gamay kay siya area. Unya ang force mo kung panitan kusgon nimo og duot. Unya gamay kay siya area, so mo nang maka-slice ta og ang mga vegetables ana ba. So for example, kung mahabol ba imong kung mahabol ay imong kutsilyo, ang imong buhaton is bairon nimo siya. So ang ginabuhat nimo ana is ginapagamay nimo ayo ang area. So pag slice nimo gamay kay nga area unya dako ang force nga gigamit nimo, so ang pressure niya is dako gid siya ang pressure. So dako ang pressure mo din ang ma-slice na to ang mga vegetables. So next is the pressure at a depth. The pressure at a depth in a fluid of constant density is calculated using the formula P is equal to P of 0 plus VGH, where P of 0 is atmospheric pressure, P is the density of the fluid, and G is the acceleration due to gravity. So example sa sa pressure at a depth. So example natay container. So na siya sa sulod nga tubig. Ang depth niya ni is 3 meters. 3 meters. So ang formula sa pressure at depth is total pressure is equal to atmospheric pressure plus rho G-8, where rho is the density, G is the gravity, and H is the height or the depth. So the value of pressure atmospheric pressure, that is 101.3 kilopascal, and then the density is 1000 kilogram 1000 kilogram per cubic meter, and then the gravity is 9.8 meter per second, and our depth is 3 meters. So let us substitute this in our formula. So we have PT is equal to 101.3 kilopascal plus the density, which is 1000 times 9.8 meter per second squared times 3 meter. So we should get subs na to guys, 1.31 times 10 raised to 5 Pascal. Sama na itong answer. So, pressure. Variation of pressure with depth. The pressure in fluid with varying density is calculated using differential equation. dP over dy is equal to negative rho gh, where y is the vertical coordinate. This equation shows that the rate of change of pressure is proportional to the density of the fluid. Example is example natay tank. Tank na siya water diha, and then ang iyang depth is 3 meters gyapon. Mo ni iyang dy o dy na siya, mo ni iyang dy, and then gravity na to is 9.8 meter per second square, and then itong density, itong rho, is equal to 1000 kilogram per meter cube. So ang density ana niya diri 1000 kilogram diri. So gamiton na itong formula, which is dP over dy is equal to negative P rho gh. This is equal to negative rho is 1000 times gravity, which is 9.8, times the depth, which is 3 meters. So this is equal to 29,400 Pascal. So next is measuring pressure. So we have gauge versus absolute. So gauge pressure. Gauge pressure is measured relative to atmospheric pressure, while absolute pressure includes atmospheric pressure. So absolute pressure is the sum of gauge pressure and atmospheric pressure, or in equation form, absolute pressure is given by gauge pressure plus atmospheric pressure. So next is pressure measurement devices. Various devices are used to measure pressure, including strain gauges, capacitance, pressure gauges, um, piezoelectric pressure gauges, and ion gauges. Manometers. So manometers, often using a U-shaped tube filled with a liquid mercury, are used to measure pressure differences. The height of difference in the liquid column directly corresponds to the pressure difference. Next is barometers. Barometers, typically using a single column of mercury, are used to measure atmospheric pressure. The height of the mercury column is proportional to the atmospheric pressure. So next is the Pascal's principle and hydraulics. So, Pascal's principle. This principle states that any change in pressure applied to an enclosed fluid is transmitted to all parts of the fluid and the container walls. So, hydraulic system utilize Pascal's principle to transmit force and power by applying a force to a smaller piston. A larger force can be exerted on a larger piston due to the pressure being transmitted undiminished throughout the incompressible fluid. So ang gingon ni Pascal's principle is any change in pressure applied to a completely enclosed fluid is transmitted and diminished to all parts of the fluid and the enclosing walls. So ang keyword ni Modra is enclosed fluid. So ang imuhang fluid is nakabutang siya sa confined container. So pasabot confined, wala gi hangin nga makasulod siya, only fluid lang gid ang nasa ihang sulod. So ginaingon sa Pascal's principle is that ang pressure sa isa ka confined container is the same ra siya all throughout tanan. So kung nag-apply ta pressure diri sa pikas nga kuan, tawagan na siya P1. So ang pressure nga iyang gikuandra is dili siya mawala. So ang pressure is nara siya sulod sa container, no. So ang pressure sa P1 ug sa P2 is similar siya. So di ba ang formula nato sa pressure is force over area. So ang gyapon gikan ang formula sa Pascal's principle, which is F1 over A1 is equal siya sa F2 over A2. For example, no, is mga hydraulic lift, at makita niyo nato siya sa mga car repair shop. Mo ni siya ang ginagamit para maangat ang mga cars nga kinahanglan i-repair. So ginagamitan na siya og gamay kayo nga amount of force para maangat tong mga cars nga kinahanglan i-repair. So ang pressure nga imong gi-create sa imong input kini diri sa imong kanang naitaw-tawo is similar na siya sa imong pressure nga sa imong output, which is dira sa dapit sa sakinan. So sa ato ang example, a 2,000 pound car is lifted by a manually operated hydraulic lift. The area of the shaft of the lift is 80 square centimeter. The area of the piston that forces liquid into the system is 2 square centimeter. What force must be exerted on this piston to lift the car? So I identify sa nato tong given, which is F1, A1, F2 and A2. So i-assume na to ang atong input is F1 and A1, atong output is F2 and A2. So ang 2,000 pound car nato mo nato siyang F2, and then the area of the shaft, which is 80 square centimeter, mo na ato ang A2. And then ang ato ang liquid into the system is 2 square centimeter, mo na ato ang A1. So ang pakitao na to is ang F1 o the force, mo na siyang force nga i-exert na to. So by Pascal's principle, which is F1 over A1 is equal to F2 over A2. So ato ra siya i-cross multiply para makuha natong F1. So since F1 man atong ipangita, no, so atong i-isolate ni F1 by dividing A2 both side. So pwede na ta mag solve. Ato na lang i substitute ang mga value. So makancel na to ang duha ka square centimeter, no? So ang mabilin na lang ang unit is pound. So kung isolve na to, ang answer na to is 50 pound. Next is the Archimedes principle and buoyancy. So buoyant force, an upward force known as buoyant force, is exerted on any object submerged in a fluid. This force arises from the pressure difference between the bottom and top of the object due to the increasing pressure with depth. So ang giingon daw sa Archimedes principle, no? So any object completely or partially submerged in a fluid experiences a buoyant force equal in magnitude to the weight of the fluid displaced by the object. So ang pasabot ra nino is if na kay object di siya ingon nga fully completely kon siya submerged, pwede nga partially submerged ra siya sa fluid. So example ana is kuan if mag-swimming ta. So kung mag-swimming ta is maka-experience ta og buoyant force. Mo nang ma-feel na to nga if mag-swimming ta is mura gaan kay atong lawas ba. So atong buoyant force mo to siya ang gatulak sa ato pababaw. So ang buoyant force na to is equal ni siya sa weight of the fluid displaced. So sa equation form, ang formula to sa buoyancy is kuan FB is equal to mfg, where mf is the mass of the fluid. So important points, no? So for an object that is fully submerged in fluid, so meaning naka-sink gid siya sa tubig, so ang imong volume sa imong displaced fluid is equal ra sa volume sa imong object. So kung unsay weight sa imong object is mo na ang equivalent sa imong buoyant force. So pwede ka po na ito i-calculate ang buoyant force using the formula weight of air minus weight of fluid. So sa itong example, no, calculate the buoyant force on a rock of mass 32 kilograms and density of 2,800 kilograms cubic meter when fully submerged in water of density 1,000 kilogram cubic meter. So ang given nato is mass is equals to 32 kilogram, and then ang density nato sa rock is 2,800 kilogram per cubic meter. So ang ato ang liquid ring nga involved is water. So ang given sa water is density sa water is 1,000 kilogram per cubic meter. So giingon sa to ang problem dire, no, is fully submerged. So pasabot ang volume sa imong rock is equal ra siya sa volume sa imong water. So kaning water ni kining volume sa imong water is VH2O is mo na siya ang displaced water. So i-calculate na to ang volume, no. So balik ta sa formula sa density. So pag-calculate sa volume is baylo ra ta ng rho og ang V para makuha ang volume. So by substitution, so makancel na to ang kilogram nga unit, no. So ang makuha na to diri is 0.011 cubic meter. So since similar ang volume sa rock o ang volume sa water, so ang ato ang volume pud sa ato ang water is 0.011 cubic meters. So pag i-compute na to ang buoyant force is ang formula is FB is equal to root G V. So ang atong gina-solve diri is about na sa water, no. So ang atong butang diri nga given is katong 1,000 kilogram per cubic meter. And then the G, which is the gravity, which is 9.8 meter per second. So ang volume na to nga atong nakuha is 0.011 cubic meters. So makancel na to ang cubic meter, so mabilin ang kilogram o meter per second squared. So equal na siya sa Newton. So ang kung makuha na tong answer is 107.8 Newton. Archimedes principle. This principle states that the buoyant force on an object equals the weight of the fluid it displaces. Sa pasabotan niya is if naa kay container nga puno, unya naa kay gibutang nga object sa atong container, syempre maawas magito siya. Katong moawas nga tubig daw, equal po daw siya atong kuan, atong gibutang ni mga object equal iyang kabug-aton nato niya. So kaning nga wala nga tubig mo na siya ang fluid, displaced fluid. So kining displaced fluid equal rin siya sa buoyant force. Ang buoyant force mo na itong FB is equals WFL. Density and Archimedes principle. The average density of an object determines whether it floats or sinks. If the object's density is less than the fluid's density, it will float. Fraction submerged. The fraction of a floating object submerged is equal to the ratio of the object's density to the fluid's density.
Ang Archimedes principle ay tungkol sa tinatawag na buoyant force. Ang buoyant force ay isang force na nafe-feel ng isang bagay kapag nilubog mo siya sa isang fluid. Ang gagamitin nating symbol para sa buoyant force ay B, at ang direction ng force na to ay palaging pataas. Kapag nagsiswimming tayo, ang buoyant force ang dahilan kung bakit tayo lumulutang. Pero bakit may mga bagay na palaging lumulubog? Ibig sabihin ba nun, pili lang ang mga bagay na nakaka-experience ng buoyant force? Para malinawan tayo, subukan natin mag-derive ng equation para sa buoyant force. Meron tayo ditong object na hugis kahon na nakalubog sa isang fluid. Pwede namang ibang shape, pero mas madali ang pag-derive kapag hugis kahon siya. Sabihin natin ang height ng object ay h, at ang areas ng top at bottom sides ay a. Natutunan natin sa nakaraang video na may na-apply na force ang fluid sa 6 na sides nitong kahon. Magka-cancel out lang yung forces sa gilid, pero sa ibabaw at sa ilalim, magkaiba ang lakas ng force. Sabihin natin ang pressure sa ibabaw ay P-top, at ang pressure sa ilalim ay P-bot. At gaya ng natutunan natin sa nakaraang video, equal to sa P-top plus rho G-H. Since pressure is equal to force over area, pwede natin isolve ang magnitude ng force sa ibabaw at sa ilalim kung i-multiply natin ang pressure sa area ng top at bottom sides. So ang force sa ibabaw, F-top, ay equal sa P-top times A. At ang force sa ilalim, F-bot, ay equal sa P-bot times A, na equal din sa P-top times A plus rho G-H times A. Ang buoyant force ay ang net force na ina-exert ng fluid sa object. Since nag-cancel out na yung forces sa gilid, equal na lang to sa net force ni F-top at F-bot. Since magkaiba ang direction nilang dalawa, dapat magkaiba din ang signs nila. Gagawin ko negative yung pababa. So ang buoyant force ay equal sa F-bot minus F-top. Plug-in natin yung expressions ng forces in terms of pressures. Ang lalabas, P-top times A plus rho G-H times A minus P-top times A. Uy! Magka-cancel out yung terms na P-top times A. Ang matitira, rho G-H times A. Pero ano ba yung H times A? From geometry, equal lang yan sa volume ng object. So ang buoyant force ay equal sa rho V G. Lagyan natin ng subscripts yung mga quantity na para sa fluid at para sa object para hindi tayo malito mamaya. Itong rho ay density ng fluid at itong V ay volume ng object. Paano kung hindi nakalubog ng buo yung object? Ganun din naman. Sa ibabaw, meron kang force F-top at sa ilalim, meron kang force F-bot. Pero iba na ang values ng pressures. Yung ibabaw, hindi na siya nakalubog sa fluid, pero exposed siya sa atmosphere. So ang pressure dyan ay atmospheric pressure. Dito sa ilalim, pwede mo pa din gamitin na equation na P-bot equals P-top plus rho G-H. Pero ang tatayong P-top mo ay itong surface ng fluid, na may pressure na atmospheric pressure. Tapos ang H mo ay ito na lang. Magka-cancel out pa din ang forces sa gilid. So ang buoyant force ay equal pa din sa F-bot minus F-top. Plugin natin yung expressions na forces in terms of pressures. Ang lalabas, P atmosphere times A plus rho G-H times A minus P atmosphere times A. Uy! Magka-cancel out yung terms na P atmosphere times A. Ang matitira, rho G-H times A. Pero ano ba tong H times A? Since iniba natin ang definition ng H, hindi na to equal sa buong volume ng object. Equal na lang siya sa volume ng object na nakalubog sa fluid o yung tinatawag na volume submerged, V sub. So, ang buoyant force ay equal sa raw fluid times V sub times G. Note na yung expression ng buoyant force para sa isang object na fully submerged, makukuha mo rin siya dito kung papalitan mo ang V sub ng V object. Merong magandang interpretasyon nitong buoyant force. Kung maaalala nyo, ang density ay mass over volume. So ang mass ay density times volume. Itong raw fluid times V sub, pwede mo siya i-interpret bilang mass ng fluid na kasing dami ng volume ng object na nakasubmerge. Pwede din ganito. Kunwari pinuno mo muna ng tubig yung lalagyan, tapos nilagay mo yung object, edi may matatapon. Yung raw fluid times V sub, pwede mo siyang i-interpret bilang mass ng natapong fluid o yung tinatawag na displaced fluid. So yung M displaced times G, pwede mong i-interpret bilang weight ng natapong fluid. So ganun lang pala yun. Ang lakas ng buoyant force ay equal sa weight ng natapong fluid. Ito ang tinatawag na Archimedes principle. When an object is completely or fully immersed in a fluid, the fluid exerts an upward force on the object equal to the weight of the fluid displaced by the object. Sabi sa Archimedes principle, basta may part ng object na nakalubog sa fluid, automatic na merong buoyant force na ma-feel yung object. Pero bakit may mga bagay na lumulubog sa tubig? Ito ay dahil, para sa mga object na lumulubog, mas malakas pa rin ang weight kaysa sa buoyant force. So may net force ka pa din na pababa. Pwede pa natin masimplify ang inequality na to. Ang weight ng object ay equal sa mass ng object times G. Itong mass ng object, pwede mo siyang isulat bilang density ng object times volume ng object. Ang buoyant force ay equal sa density ng fluid times volume ng object times G. O, pwede mag-cancel out yung V at G sa magkabilang side. Ang matitira ay densities. So kapag pala lumulubog ang isang object sa isang fluid, ibig sabihin nun, mas malaki ang density ng object kaysa sa density ng fluid. Paano naman kapag mas maliit ang density ng object kaysa sa density ng fluid? Mag-multiply lang tayo ng V object at G sa magkabilang side. Ito, equal sa weight. At ito, equal sa buoyant force. So mas malaki ang buoyant force kaysa sa weight. Ibig sabihin, meron kang net force pataas at gagalaw ang object pataas. Ibig sabihin ba nun, pagdating sa surface ng fluid, aakyat yung object papuntang langit? Siyempre hindi, pero subukan nating i-analyze kung bakit. Kapag yung object nasa surface na ng fluid, liliit na yung volume submerged. So, liliit na din ang buoyant force, hanggang umabot sa point na magsinglaki na ang weight at buoyant force. So eventually, lulutang yung object. Magbigay tayo ng example. Kunwari, meron kang iceberg na nakalutang sa dagat. Ang density ng iceberg ay equal sa 920 kg per meter cube. Ang density naman ng dagat ay 1,030 kg per meter cube. Since mas maliit ang density ng iceberg kaysa sa density ng dagat, alam natin na lulutang ang iceberg. Pero ang tanong ko dito, anong porsyento ng iceberg yung nakalubog sa dagat? Since nakalutang ang iceberg, equal ang weight ng iceberg sa buoyant force na ina-apply ng dagat. Itong weight, pwedeng isulat as density ng object times volume ng object times G. Ito namang buoyant force, from Archimedes principle, pwedeng isulat as density ng fluid times volume submerged times G. Magka-cancel out yung G sa magkabilang side. Ilipat natin lahat ng volume sa left-hand side at lahat ng density sa kanan side para maging V sub over V object equals raw object over raw fluid. Bakit natin ginawang ganyan? Kasi yung V sub over V object, yan yung fraction ng iceberg na nakalubog sa dagat. Para makuha mo yung percentage, multiply mo lang both sides by 100%. So ang porsyento ng iceberg na nakalubog sa dagat ay equal sa raw object over raw fluid times 100%. Mag-substitute na tayo ng values. Ang lalabas na sagot dito ay 89%. So yung nakikita natin na iceberg sa mga palabas, 11% lang yun ng total volume ng iceberg.
So next is fluid mechanics. Flow characteristics. The motion of a fluid is characterized by flow rate, velocity, and viscosity. First is the laminar flow. In laminar flow, fluid layers move smoothly and parallel to each other without mixing. Next is turbulent flow. In turbulent flow, fluid layers makes the exhibit irregular, chaotic motion with eddies and swirls. So the difference between laminar and turbulent is that laminar flow is a type of fluid motion where the fluid moves in smooth, orderly layers with little or no mixing between them. Each layer of fluid slides gently past the others and the overall movement is steady and streamlined. While ang turbulent flow is chaotic and irregular with swirling currents and mixing between layers. It usually happens when the fluid is moving quickly or when there are obstacles in its path. So the main difference is that laminar flow is smooth and predictable while turbulent is rough and disordered. Next is the flow rate. Flow rate, or given by the symbol Q, is the volume of fluid pressing a given point per unit time. Or in equation form, Q is equal to the dV over dt, where V is the velocity and T is time. So ang flow rate daw, muna siya ang amount of fluid that passes by a certain point in a certain amount of time. It tells you how fast the fluid is flowing. So example, if natay 10 liters of water flows out of a pipe in 2 seconds, the flow rate is Q 10 over 2, since ang change in volume na to is 10, ang atoang time is 2, so 10 divided by 2, so 5 liters per second. So ang flow rate mo na siya gina-measure ni mo kung how much fluid goes by per second para sa water from faucet. Next is the equation of continuity. This equation applies to incompressible fluids and states that the flow rate is constant throughout a closed system. So the equation of continuity says that for an incompressible fluid, the amount of, for example, the equation of continuity says that for an incompressible fluid, for example water, the amount of fluid flowing into a pipe must be the same as the amount of flowing out, as long as the pipe is closed and there are no leaks. This means that the flow rate stays constant throughout the system. So ang atong formula is A1V1 is equal to A2V2, where A is the cross-sectional area of the pipe and V is the speed of the fluid. So for example, if water flows through a wide part of the pipe slowly and then enters the narrow section, it will move faster in the narrow part, like putting your thumb over the end of a garden hose to make the water shoot out faster. So, ang tubig daw is mo increase iyang speed kung mas gamay ang ang area nga iyang ginaagian. So para sa nang gunita natong hose, di ba, pag pislito nato siya, mugamay ang iyang area nga gayaanan, mo nang mokusog ang speed sa tubig. Mass conservation. The mass flow rate, the rate at which mass moves past a point, is also a crucial quantity in fluid dynamics. The mass flow rate is constant in a closed system where there are no source or sinks. So sa mass conservation means that in a closed system where no fluid is added or removed, the mass of the fluid stays constant as it flows. Just like how water can't magically appear or disappear, the mass that goes into a pipe must equal the mass that comes out, as long as there are no leaks or sources. The mass flow rate is the amount of mass passing a point per second. It's given by so the mass flow rate is given by rho AV, where M is the mass flow rate, rho is the density of the fluid, and A is the cross-sectional area of the pipe, and V is the flow speed of the fluid. Since mass is conserved, P1 A1 B1 is equal to P2 B2 A2. If the fluid is incompressible, same density meaning same density sa everywhere, this reduces to the equation of continuity. So mahimo na din ihang formula mag A1 B1 is equal to A2 V2. So mass conservation, ang pasabot ra ana niya is kung unsay mo sulod dapat maupot siya ang magawas. And we account for both speed and density. Next is the Bernoulli's principle. Bernoulli's principle states that an increase in the speed of fluids occurs with a decrease in a pressure or decrease in the fluid's potential energy. Next is the Bernoulli's principle. Bernoulli's principle states that an increase in the speed of a fluid occurs with a decrease in pressure or decrease in the fluid's potential energy. Video. Energy conservation. Bernoulli's equation is derived from the principle of energy conservation. Applied to frictionless, incompressible fluids, it relates to pressure, velocity, and height along a streamline. So Bernoulli's equation this equation shows that the sum of pressure, kinetic energy, and density and potential energy density remains constant along a streamline. So ang pasabutan niya, ang giyon niya is for frictionless incompressible fluid flowing along a path called a streamline, the total energy stays the same. This energy comes in three forms. First, pressure energy from the fluid being pushed, kinetic energy from fluid moving, potential energy from the fluid's height. So atong formula sa atong Bernoulli's equation is P plus 1/2 rho V square plus rho GH is equal to constant, where P is the pressure, rho is the fluid density, V is the speed of the fluid, and G gravity, H is height or the Y. So, ang pasabot daw is, if the fluid speeds up, pressure goes down. If the fluid goes higher, pressure might go down. All the energy shifts down but the total stays the same. So kining sa pipe, so ang tubig nga flow aning pipe sa narrow nga section mupaspas ang iyang ang iyang flow. Pero ang iyang pressure ni drop. Dayon sa wider section mo slow down iyang flow pero ang iyang pressure is mo increase. So mo ni siya ang sa explanation sa airplane, no? So if air goes faster over the top of the wing, mo rin na makakuan siya og lower pressure. Then mo rin na nga maka-create siya og lift pa hinungdan nga makalupad ang airplane. So Bernoulli's principle, a special case of Bernoulli's equation. So Bernoulli's principle, a special case of Bernoulli's equation for fluids at a constant depth. This principle states that pressure decreases as speed increases in a moving fluid. Balik lagi ni. Application of Bernoulli's principle. Many devices and situations utilize Bernoulli's principle, including entertainment devices, velocity measurement instruments, and the flow of fluids through pipe. Viscosity and turbulence. So, viscosity. Viscosity is a measure of fluid's resistance to flow. It is a property that reflects internal friction within a fluid and between the fluid and its surrounding. So, ang viscosity daw is muna siyang measure o unsa ka thick or sticky ang fluid. So, it tells us how much the fluid resists flowing. It happens because of internal friction between layers of the fluid as they slide past each other, and also between the fluid and the walls of its container. For example, kung high imong viscosity, so ang imong fluid ana slow iyang flow. Tapos kung kuan siya thicker or stickier ihang kuan. For example, na kay honey, kung ang honey is high og viscosity, mo nang hinay ang flow. Dayon, mo na siya thicker ihang murag sticky siya ba. Dayon kung low imong viscosity, fluid flows easily and then ang fluid is thinner. For example, ang water, so dali ra kay siya magpaspas ihang flow. So ang symbol for viscosity is kining murag letter N. Ang pabasaan is eta. Laminar flow, laminar flow confined to tubes. Ano sa'yo pagbasa ni? Edit. Pressure drops due to resistance. Pressure drops occur in fluid flow due to viscosity and turbulence. This pressure drops is related to the flow rate and the resistance. So, Posi's solo daw, law tells us how much fluid flows through a cylindrical tube, like pipe or blood, example, blood vessel. When the flow is laminar or smooth and the fluid is viscous and incompressible, like water or oil. So, ang key ideas na to is, kung bigger yung pressure difference, the faster the fluid flows. The wider the tube or larger yung radius, much more flow because dako man ang kuan ang iyang agyanan. So, pag higher viscosity or longer tubes, slow iyang flow. So, if you double the radius of a tube, the flow rate increases 16 times. Next is Reynolds number. The Reynolds number, or NR, is a dimensionless quantity that helps predict whether flow is laminar or turbulent. For NR, okay. So ang viscosity daw is mo na siyang measure o unsa ka thick or sticky ang fluid. So it tells us how much the fluid resists flowing. It happens because of internal friction between layers of the fluid as they slide past each other, and also between the fluid and the walls of its container. So example, kung high imong viscosity, so ang imong fluid ana slow iyang flow. Tapos kung kuan siya thicker or stickier iyang kuan. For example, na kay honey, kung ang honey is high og viscosity, mo nang hinay ang flow. Dayon, mo na siya thicker iyang murag sticky siya ba. Dayon kung low imong viscosity, fluid flows easily and then ang fluid is thinner. For example, ang water, so dali ra kay siya magpaspas iyang flow. So ang symbol for viscosity is kining murag letter N. Ang pabasaan is eta, and it's so Posi's solo daw, law tells us how much fluid flows through a cylindrical tube, like pipe or blood, example, blood vessel. When the flow is laminar or smooth and the fluid is viscous and incompressible, like water or oil. So, ang key ideas na to is, kung bigger yung pressure difference, the faster the fluid flows. The wider the tube or larger iyang radius, much more flow because uh, dako man ang kuan ang iyang agianan. So, pag higher viscosity or longer tubes, slow iyang flow. So, if you double the radius of a tube, the flow rate increases 16 times since R. Next is terminal speed for an object. Next is terminal speed. For an object moving through a fluid, terminal speed is reached when the drag force due to viscosity equals the gravitational force. So, sa Reynolds number, so as fluids through a pipe or tube, it loses pressure. So pressure drops due to resistance. As fluid through a pipe or tube, it loses pressure drops due to resistance. As fluid flows through a pipe or tube, it loses pressure along the way. This happens because of viscosity, which is the internal friction between fluid layers, turbulence, which is the chaotic motion when the fluid moves too fast or hits obstacles. So the faster the fluid moves, the more resistance. So like narrow tubes or thick fluids. So the more pressure drops between the start of the end of the pipe. So ang formula sa Reynolds number is given by rho VD or given over N or viscosity. So ang D diri is the diameter of the pipe. So ang giingon sa Reynolds number is pag imong Reynolds number is lower than 2,000, so ang iyang is laminar flow or smooth and steady. If ang imong Reynolds number is greater than 4,000, then ang man is turbulent flow. So chaotic siya and mixed. So kung na siya sa in between, so kana siya is transitional flow at tawag na siya, balin-balin siya. So example, water flowing slowly in a narrow pipe. Kung low iyang Reynolds number, so laminar na siya. If a water moving fast in a wide pipe, so high iyang Reynolds number, so turbulent siya. So ang purpose sa Reynolds number, it helps predict pressure drops because turbulence causes greater energy loss and faster pressure decrease. So kining terminal speed, it is the constant speed of an object reaches when falling through a fluid like air or water. When the object falls, gravity pulls it downward, while the fluid pushes back on it with a drag force. So drag force, this is the resistance due to viscosity. As the object speeds up, the drag force increases. Eventually, the drag force becomes equal to the force of gravity, and at that point, the object stops accelerating and continues falling at constant speed, which is called the terminal speed. So that's all, guys. So thank you so much for listening.